sorry, I had to pause it. Okay, you need to watch this. If your change in temperature is greater than 16.8, you have to consider both situations. Okay, but ours is not. We have 7. Okay, so this is someone who's been dead less than 12 hours or no more than 12 hours. Okay, step 2, you have to use the ratio. So a body loses in the first 12 hours 1.4 degrees Fahrenheit per hour. Whoops, I guess I had to divide there. I don't need that. In the first 12 hours. Okay, so I'm going to take my 7 degrees Fahrenheit and divide by the rate, 1.4. Okay, so 7 divided by 1.4, that gives me 5. So we can say that this person has most likely, given normal conditions, been deceased for about 5 hours. Okay, so if it's under 12 hours, if this number is under 16.8, you just have to do one step after. Okay, let's try a more complex one. A body was found with a temperature of 74 degrees Fahrenheit. How long can you assume they've been dead for? Okay, remember, we're always starting with 98 degrees Fahrenheit. So step 1. So 98 degrees Fahrenheit, that's our starting temperature. Healthy living person minus the temperature at which they were found equals 74. So do that math. That equals 24. Okay, but remember, in the first 12 hours, you can only lose up to 16.8, and that's just mathematically, if you figure it out, that's the most you can lose. Okay, so this person's been deceased for more than 12 hours because they have a change in 24 degrees. Okay, so that was step 1. Step 2, I know that they lost this much heat in the first 12 hours. I know that. How much body heat did they lose the second half? So I have to take 24 minus the first 12-hour loss, which gives me 7.2. So in the after 12 hours, they lost 7.2. Okay, so I know they've at least been dead for 12 hours because they at least lost 16.8, and then they lost some more. So now I know 12 hours. I've got 12 hours banked. Now I need to figure out how many more hours. So step 3, I'm going to take 7.2. And remember, in the second set, if you have over 12 hours, which I know I do, it's only a change of 0.7 per hour. So I'm just going back to this and now using this number. So after the first 12 hours, you only lose 0.7 degrees per hour. Okay, so that's going to give me a number of about 10.29. Okay, so that's how long they've been deceased after 12 hours. Now I need to know the total. How long have they actually been deceased for? Well, I'm going to take the first 12 hours. I know they were at least deceased for 12 because my change in temperature was over that 16.8 threshold. So I've got 16.8. Whoops, that's not what I need. Sorry, I've got my first 12 hours plus I now figured out they've also been deceased for another 10.9 hours. So how long has this person been deceased for? We can assume they've been deceased for about 22.29 hours. Okay, so that's just making it a little bit more complex because they've been deceased over 12 hours. So I first had to figure out they were dead for 12 hours because the threshold is 16.8. I subtracted that number from the change in temperature. So they lost 16.8 degrees in the first 12 hours. They lost 7.2 degrees after 12 hours. And then I did the math to figure out that total number of hours after 12. I added the first 12 hours plus the excess hours, and I got that the deceased was dead for about 22.29 hours. That's pretty much as complex as this could get. All right, let's try one more. Approximately how long has a person been dead if his body temperature was 91.6? Okay, so step one, figure out the change in temperature. Always start with 98 minus the temperature at which they were found. That gives me a change in temperature of 6.4. So this person has not been dead more than 12 hours because it hasn't hit that 16.8 degrees threshold. So they lost this much heat since they passed. Okay, I'm now going to take that number and in the first 12 hours, you lose 1.4 degrees per hour. So I'm going to divide, and this gives me 4.56. So I can assume that this person has been deceased for about 4.5 hours. Okay, so that's how you actually figure out Algor mortis examples. But remember, this is not the sole indicator of death. You have to also consider rigor mortis and livor mortis. So just a fun fact, I guess you could say, a body will actually cool in still water twice as fast as it will cool in the air. So if you find a body that's in water, standing water, you have to consider that in your calculations. It changes things. A body in cool running water will cool about 3 times faster than just in the air. So if someone's in a river that's rushing, their body's going to cool even faster. So things to consider when doing Algor mortis examples, but I won't ever complicate it for you that much. So specific things that can affect the Algor mortis temperature. Body surface, okay? Someone who's thin will lose body heat faster than someone who's heavier. The body position. If someone is fully extended, giving more surface area to the air or whatever condition they're in, versus if they're curled up tight. Think about if you're cold, you like to scrunch up. That conserves your heat. The clothing on the body obviously will affect the heat lost. If they're very, very tightly bundled out in the cold, that would insulate them a little bit more. Retention of fluids slows heat loss. So someone that has a condition that causes them to retain fluids, congenital heart failure, things like that, they'll actually lose heat more because the fluid absorbs the heat. If you're in a cooler or windier environment, you will obviously lose heat faster because it's cooler outside. And then if a body is submerged, and the actual water temperature itself will affect ambient temperature, and therefore the Algor mortis. So just a little rule of thumb for determining postmortem intervals or time of death. This is kind of putting it all together. If the body is warm to the touch but is limp, the person's probably been dead for less than 3 hours, because remember, rigor mortis does not start setting in until 2 hours, and it takes 12 hours to peak. If the body feels warm but is relatively stiff, you can assume that the person's been dead about 3 to 8 hours, give or take. Rigor mortis does not set in officially till 12 hours, but at that time you've also lost 16.8 degrees. So if they're still kind of warm but stiff, you can extend it 3 to 8-ish. If the body feels cool and they're still stiff, you know that they've at least been deceased for 12 hours because rigor mortis has peaked. And because you lose more body heat the longer you've been deceased, your body's going to be cooler. So if you're still very stiff, but you feel cold, like I said, this is not a perfect science estimation. This is just kind of guesstimating about 8 to 26 hours. And then if the body is cold but limp, it means the rigor mortis has completely left the body. And if it's cold, the body's been person's been deceased for a long time, you can assume more than 36 hours. Okay, so that's just a general estimation using all three mortises. But like I said, you have to consider them all together very scientifically with calculations to give a really great time of death estimation.